There's something chilling about the phrase black hole. It sparks a sense of danger, mystery, and an unsettling warning. You've likely heard that it's a void, an all-consuming darkness that devours everything in its path. Many say it's a place where time ceases to exist and the very laws of physics break down. This cosmic enigma is so mind-boggling that even the brightest minds struggle to truly comprehend it. In this video, we're diving deep into one of the universe's greatest mysteries. What happens when you fall into a black hole? Buckle up, because the truth is stranger than you could ever imagine. From the crushing forces of gravity to the mind-bending manipulation of time, let's explore the bizarre and terrifying fate that awaits anyone unlucky enough to fall in. To truly understand the chilling power of a black hole, we first need to grasp what it actually is and how it comes to be. So, a black hole is a region in space where gravity is so strong that nothing can escape its pull, not even light. This makes it completely invisible, which is why it's called a black hole. The force of gravity is so powerful because all the mass of the black hole is packed into an incredibly small and dense point called a singularity. Black holes are formed when massive stars, much larger than our sun, run out of fuel. For most of a star's life, it stays stable by balancing the force of gravity pulling inward and the pressure from nuclear reactions pushing outward. But when a star burns through its fuel, gravity starts to take over, causing the star to collapse under its own weight. As the star shrinks, it becomes denser and denser and denser, and eventually, it forms a black hole. That point where the star has collapsed into is called the singularity, and the boundary surrounding it is called the event horizon. Once something crosses this boundary, it can never escape, not even light, making black holes one of the most mysterious objects in the universe. Now that you know what a black hole is and how it is formed, it's time to put on our strongest spacesuits as we approach and pass through every layer of the black hole. Imagine that you are already in space with your fancy and flashy spacesuit, drifting closer and closer to a black hole. The vastness of space surrounds you, and everything seems calm, but there's a boundary you can't see. Suddenly, you cross it. You don't realize it at first, but you've crossed the event horizon, the point of no return. This invisible line marks the moment when nothing can escape the black hole's grip. At this point, something strange happens. To you, the outside world may seem the same, but to an observer far away, time begins to slow down for you. The closer you get to the event horizon, the slower time seems to move. It's as if you're frozen in time, stuck in an endless moment, forever. As you continue to pass through the event horizon, the gravitational forces around you become so immense that they begin to warp space and time itself. These forces act like invisible hands, relentlessly pulling you closer, stretching your body from head to toe in a process known as Spaghettification. It's exactly as dramatic as it sounds, but far from any fun. The pull at your feet is stronger than at your head, gradually elongating your body, making it thinner and longer, just like a piece of spaghetti. As the force intensifies, things quickly spiral out of control, and you reach the point where everything begins to break apart. Now, you're in a region where communication with the outside world becomes impossible. No signals, be it light, radio waves, or any form of energy, can escape. From the moment you cross the event horizon, you're cut off entirely, severed from everything you knew. No matter what happens next, you're utterly isolated, trapped in the heart of a cosmic prison beyond the reach of the rest of the universe. As you sink deeper toward the very center of the black hole, you reach the singularity, a point where gravity is so powerful that it distorts space and time beyond recognition. At this core, everything becomes so dense that the usual rules of physics break down entirely. The gravity here is so extreme that it crushes everything into a single, infinitely small point, causing space-time itself to collapse. It's a place where our understanding of the universe stops, leaving only the unknown. Although we have some ideas about what might happen to you in the singularity, the exact details remain a big mystery. One thing is certain, though. you won't survive. The forces inside a black hole, spaghettification, crushing gravity, and the collapse of space-time, combine to make survival impossible. Scientists have proposed several theories about what might happen, but since no one can survive to observe it firsthand, we can't know for sure. One fascinating theory is that the singularity at the heart of a black hole might actually be a doorway to another universe. Imagine it as a tunnel or a shortcut that could connect distant parts of space or even lead to entirely new dimensions we can't yet comprehend. This concept is known as the wormhole hypothesis, a theory proposed by physicist Kip Thorne. Thorne suggested that black holes might act as cosmic bridges, providing a pathway not just to far-off areas within our own universe, but possibly to entirely separate universes. While this idea remains theoretical and unproven, it has inspired both scientific research and science fiction, offering a glimpse into how black holes might reshape our understanding of space and time. Another intriguing idea, introduced by Stephen Hawking, is the information paradox, which questions what happens to the information about an object's physical makeup when it falls into a black hole. According to the paradox, all that information, describing the object's structure, properties, and quantum state, seems to disappear once it crosses the event horizon. However, this contradicts a fundamental principle of quantum mechanics, which states that information can never be lost. This contradiction has sparked intense debates among scientists for decades, and while various solutions have been proposed, such as Hawking radiation potentially releasing information or theories involving quantum entanglement, a definitive resolution remains elusive. Lastly, some scientists, like Carlo Rovelli, have a different idea called loop quantum gravity. This theory suggests that space and time might work differently at incredibly tiny scales, where our usual understanding of physics breaks down. Instead of being smooth and continuous, space and time could be made up of tiny separate building blocks, like pixels in a digital image. If this is true, the singularity, the point of infinite density at the center of a black hole, might not exist as we imagine it. Instead, the core of a black hole could have a well-defined structure, something finite and less extreme. This idea challenges our current understanding of black holes and opens up new possibilities for how the universe works at its most fundamental level. The journey into a black hole is one of the most mind-bending and terrifying scenarios in the universe. Once you cross the event horizon, everything you know about time, space, and survival breaks down. Despite fascinating theories, the truth remains elusive. What we do know is that black holes are one of science's greatest mysteries, challenging our understanding of the cosmos. As we consider the fate of those who fall in, we are left with the ultimate question: can we truly understand what happens at the edge of existence? Perhaps a black hole isn't just a place of death, but a doorway to something greater, revealing secrets we've only begun to imagine. The answers may lie just beyond our reach, in the darkness. Thanks for tuning in to our journey through space. If you enjoyed exploring interesting stories with us, don't forget to hit that subscribe button. What topics do you want us to dive into next? Let us know in the comments. Join us as we get animated about science here at Animated Science.